Hi, everyone, and welcome to the SVG Tech Tour for Infrastructure Products. This is Part A. There is also a Part B, so be sure to check those out. Part A features EVS, Imagine Communications, Lawo, Nevion, and Riedel, while Part B features Adder, IHSC, USA, MarkerTech, and Vitech. Before we get into the conversation, I had a chance the presentations. I had a chance to talk with Mike Francis, CBS Sports VP of Remote Engineering, about the infrastructure products. So please welcome Mike Francis. Mr. Francis, good to see you as always. How are things in CBS land? I know it's been a challenging time with the football, and you got some college hoops. So how are things going so far?
Things have been, going as well as can be expected. It's obviously very fluid and feels like a moving target at times, but we've learned a lot, as I'm sure everyone has, over these last several months, and have put some practices and technologies in place to allow us to be more agile in these situations. And so far, we're staying on the air, and our product is looking as good as ever, in my opinion. So I think it's been quite a ride. Everyone's very busy, but we're all happy to be busy.
Yeah, absolutely. So we're here to discuss infrastructure products, which are not the sexiest, from the outside of product areas. You're talking routers, encoders, decoders, and all the sort of the bits and pieces that play a really big part, obviously, in the industry. But what's your sense as far as, to me, the developments the last 2 or 3 years with respect to IP and all these products, without the developments that have been going on, what you guys are pulling off every week, what everybody's pulling off every week, would just be almost impossible, right? I mean, so what's your take on the infrastructure product lines and where they're at right now?
Sure. I think obviously the continuous transition to IP has probably been accelerated in a lot of ways, although we were pretty far down the road pre-pandemic, starting to see things, natively IP from edge to routing infrastructure, which is exciting and something a lot of us have been looking forward to. People like me do get excited about this stuff, by the way. And there's so I think that process is continuing to develop, and we're seeing replay and switchers and even starting to see cameras that are natively connecting IP now, and bringing the whole ecosystem into one network, essentially. So I think that has continued and has matured and is getting better and better each year. And with each deployment we see out in the mobile units, we're seeing a lot of the efficiencies come to fruition that we had been talking about for years. Where I think things are pivoting a little bit is the nature of distributed production and how infrastructure plays a role there. So SMPTE 2110 has been the target for acquisition, as it should be. It's uncompressed, it's no latency, similar working environments as we've always had with SDI. But now when we're trying to spread people out, not necessarily on premise, but all around the world, in some situations, that's going to require a level of encoding, and the encodings also come a long way. And how those two merge in a more seamless fashion, I think, is probably the next level we're going to see. How we get from a 2110 environment to a more lower bandwidth requirement friendly edge, where people are either on public internet at home or back at a broadcast center somewhere. But either way, when you talk about moving the level of signals, especially as we get into the 3 gigabit world, where it's going to take 3 gigabit of data to move a camera, one camera uncompressed, that bandwidth doesn't exist, right, at least at our venues here in the States. So I think how those technologies merge, how we stay IP from 2110 all the way to an H.264, H.265, SRT, WebRTC, whatever your edge transport ends up being, to get more and more signals, whether it's monitoring or contribution, to the endpoints, I think is probably the next step we're going to see, infrastructure manufacturers start paying attention to and prioritizing. I think, like I said, I think things have really come a long way, and it's been a lot of really smart people setting these standards and practices. And, I think they're going to continue to evolve, but I also think, the lessons of the pandemic will help shape, how this moves forward.
Okay, thanks again, Mike. And by the way, again, this is Tour A. So upcoming, we have EVS, Imagine Communications, Lawo, Nevion, and Riedel. And again, for Tour B, be sure to check that out as well. We have Adder, IHSE USA, and Marketech and Vitech. So with that said, let's kick things off with EVS. Enjoy.
Take a moment and imagine your production without any barriers. Imagine you're at the controls of technology that can power your most ambitious creative and business objectives. We call it Cerebrum. Are you wasting time coordinating various people to get one job done? For example, having to call an engineer to change a label on a UMD or to add someone to your talkback panel. Imagine you could have it all right under your fingertips and get your job done within a single panel. Imagine automating actions to save time, improving production results, like sending a text message when specific alarms trigger. Switch to a backup input if black is detected, or color the lights in your truck when the race starts. Cerebrum empowers you with total unified control. Everything under one umbrella system. Whether it's your routers, your intercom, tallies and UMDs, your multi-viewers, glue, camera shaders, or your replay servers. Cerebrum lets you monitor and control all of these devices via one system. Are the devices in your workflow isolated into control islands? Maybe your multi-viewer doesn't know about a video freeze detected by your UHD converter. Well, with Cerebrum, you can automatically have your multi-viewer change the border to red and have your UMD say freeze detected, enabling your engineers to quickly focus on solving the problem rather than wasting time finding it. With unified control, you can now imagine streamlining your workflow, simplifying it to satisfy your drive to do more with less and outpace your competition. And you can count on the support of our flexible business models to get you there. Here's an example of a simplified workflow. Before Cerebrum, Big Brother had 3 operators working the audio mixing desk. One for sliders, one calling out names and their channel numbers, and one person monitoring the audio quality and calling out adjustments. With this Cerebrum panel, the task is as simple as clicking on an actor and tuning the level up or down, which a single operator can do, and with better results than the previous 3. We also support your business with simple and flexible licensing. For example, licenses for device drivers are kept generic, so you can swap devices in and out of your system, regardless of make or model, without needing to talk to our sales team. Want to use a different camera model on any given day? No problem. You won't have to come to us for additional licenses or drivers. Cerebrum natively supports over 200 APIs and protocols. If your device protocol is not yet implemented, we will add it for free. Cerebrum can also control and monitor devices via SNMP. Now, besides integrating with conventional SDI routers, tallies, UMDs, sources, destination mnemonics, categories, and tie lines, Cerebrum is also fully capable of managing IP infrastructures, using, for instance, NMOS ISO 4 and ISO 5. With the addition of the IP core license and IP flow orchestrator, Cerebrum also becomes your infrastructure's software-defined network controller. Like this IP-based 4K OB truck from NEP, the leading world provider of OB and broadcast facilities. Their trucks rely on Cerebrum to control and monitor all their equipment. NEP has invested a lot in the latest IP technologies to work smarter and keep it at the top of its game. It needed an open control and monitoring solution capable of managing and adapting to these complex technology layers to deliver a reliable, seamless, and easy-to-use workflow. It was critical that NEP had the flexibility to reconfigure a system at speed, scale up and down as required, and enable some productions to be run by a single engineer with ease. This helps keep their services cost-effective. Instead of fighting with simple tasks made difficult by unintuitive and cumbersome control applications, operators can view and manage the entire workflow with ease through Cerebrum's user-friendly interfaces and simple push-button controls. The crew can quickly pre-configure systems to meet the requirements of the next project. This significantly reduces turnaround times to get the OB back on the road, saving both time, money, and enabling them to do more productions. Whether your operations are local, global, or remote in scope, Cerebrum is the cost-effective solution to power your most ambitious creative and business objectives. It enables customers, like NEP, adapt to new technologies, scale their productions, all while maintaining full and effective control. Would you like to learn more? Message me.
Hey, thanks for stopping by Imagine Communications today. I'm John Myatt. I'm here with Cassidy Phillips, and we're here to talk about what's going on in the live production world. We've invested a lot of time and effort the last couple of years in UHD and HDR and 2110 IP stuff, and you'll see it in everything we do as a company. Everything we do is about flexible approaches to whatever life throws at you. And so we've applied these technologies across a whole range of projects over the last couple of years. Cassidy, can you remind us about a few?
Yeah, that's a great point, John. We've done distributed campuses where they have maybe an SDI core and they're using IP to optimize the links between multiple venues to make it all feel like one big router under our Magellan SDNO. But we've also done professional arenas and professional stadiums where from one night it could be a concert to the next night there's a sporting event, and they're changing completely how they're producing the show on a COTS-based infrastructure. Or maybe they're even mixing in compressed workflows and legacy SDI workflows all under one control panel. So one of the keys, in addition to that control system, making it feel like one big router and maybe even enabling remote workflows for people who need to operate from home, has also been the Selenium network processor to deal with all these different media types and formats.
Yep. So, as a company, we've made our trade on processors and signal converters forever. And it used to be that you made a frame with a bunch of little tiny cards, and each card did a different thing, and you had a giant basket full of cards. Well, that's just not how the world works anymore. So instead, what we do now is we make these very flexible appliance products that then you software key into whatever you need for that show. So you can have a show that's UHD and you need a lot of UHD converters, but then the next night you're doing a 1080i show and really you need more multi-viewers because you got a lot more cameras going on. Well, you can just change around the keys and turn it into this or that depending on what life throws at you that day. And that's true whether you're in a truck or whether you're in a remote or whether you're in a venue. So this has rippled into the product, right? So a lot of our focus has been on more and more different personalities to go into this flexible fabric.
One of the really cool things is that people who deployed a Selenium network processor in 2018 to support a UHD workflow or to do some HDR conversion of some kind, they were also able to add something new like the multi-viewer personality when we rolled that out. And they had these Selenium network processors and racks with cables locked on and everything, and they didn't have to change anything about their physical setup. They just put a new personality on that SNP in the field.
Yep, we definitely had projects where people started out just needing, gateways because they had a lot of SDI stuff. And then later, as that SDI stuff became 2110, they've repurposed those SNPs to be multi-viewers, converters, or all kinds of other things. Now, SNP is a platform, and we keep introducing new personalities. So 2021 is going to be a really interesting year to watch what we do. We've got at least 4 different new personalities lined up to roll out into the SNP through the year.
Tell us a little more about how that Selenium network processor multi-viewer is optimized for live production.
Oh, well, that's the whole trick, right? Is that live production is a human-oriented thing where the operations team is part of the production. So it's a very low latency multi-viewer. But more importantly, it also manages HDR in the multi-viewer. So you can combine HDR and SDR signals into one canvas, and that canvas can be HDR or SDR. So different operating positions can see the thing they need to see. and do their job tailored to what their really workflow is for that event.
So speaking of the ability of people to see what's happening in their system and understand and operate the system as they expect, we've gone to great lengths to make sure that Magellan SDNO makes that routing system feel the way that people expect a router to feel, with that same destination source take behavior that they've become familiar with for years. So an operator could work one event at one venue and then go down the street and work at one of our venues and not have to learn everything about SMPTE 2110, for example. But one of the other cool tools that we have is PathView, right, John?
Oh yeah, PathView is really important because in the old days, you built a facility, you got a bunch of as-built drawings, they hung in a binder on the wall, and if you needed to figure out what was going where, you just pull up those drawings, you trace the wire, and you got a patch panel, and you're all set. Well, IP isn't that way, right? Everything's connected to the switches. PathView is effectively a virtual wiring diagram that shows you a live view of what's connected to what and what's feeding what in a signal plane right now. And it does things you could never do on paper because it shows you the breakaways of the audio, it shows you what's going to where, it shows you virtual reentries and how those affect the workflow, all the stuff you need to trace out what's happening. And it makes these live diagrams that are then operationally useful. You can put that up in a corner on your multi-viewer or on your desk, and as you switch the show, you see all the lines change, and it shows what's really happening.
So thank you for coming by the Imagine virtual booth, and we look forward to speaking with you about whatever your workflow needs might be and talking about system design with you.
Have a great rest of your day.
Our goal was to remain within a broadcast framework and to use the most universal uncompressed broadcast format on the market. The ST2110 suite of open standards seemed like an obvious choice.
Both trucks are actually completely identical, but we gave them different ranges of IP addresses and multicast addresses. And that is necessary actually to hook them up in the future and to be able to interconnect both trucks in a bigger environment.
We tried to use the resources inside the truck as much as possible.
It's really a full IP environment.
As far as we are concerned, this has been a revolutionary project. This new platform is far more powerful than the equipment we have worked with so far.
I think it is safe to say that our workflows have become a lot easier thanks to the VSM control layer.
In the truck we installed the VSM control system, Lawo's Virtual Studio Manager, which is controlling the complete infrastructure. It's therefore really the heart of the whole truck. The user interface which we created in the VSM software was custom designed. In the end it's developed into a full integrated system. Now of course we have the pieces of hardware, like you can see here. We have the Lawo MC256 audio console. We have on the video part the vMatrix platform, which is handling all of the audio and video signals in the truck.
As far as vMatrix is concerned, and I cannot stress this enough, we're impressed by its versatility and the fact that we now have a solution that allows us to adapt the feature set to the job at hand. We can configure the resources we need for specific production types. This boundless flexibility really appealed to us.
The whole truck is based on open standards. We use for the video SMPTE 2110-20. Clocking, of course, mandatory, is running on PTP 2110-10. And then for the audio part, that's quite unique. We use 2110-30, being a 24-bit audio stream, and 2110-31, being a 32-bit audio stream. And we use all of that combined in the truck. All of the connectivity to the video switcher is also done on 2110, so it's fully IP. All of the streams going towards the Sony switcher are controlled with VSM using NMOS as a basic protocol. For the external connectivity towards the truck, we have a whole family of stage boxes. On one side we have the video stage boxes based on the V-Matrix platform that gives a flexible connectivity of 20 SDI connections which can be used as inputs or outputs. In the same video stage box we provided also the AMIC 8, which is one of our smallest audio stage boxes. On the other side we have the audio stage boxes based on the power core with 24 mic preamps, some line outputs, AES-3 in and outputs, some MADI connectivity with sample rate conversion and also some local Dante connectivity. On top of that we also provided a DALIS stage box with a dynamic range of going up to 128 dB. All of the multi-viewers which you see in the truck are based on the V-Matrix platform and are configured with a DMV. The physical size of the whole system, it fits in 12 rack units of equipment.
The RTBF twins are very flexible because you can get anything in and anything out. If you want it to be on the internet, you take the streamer output. If you want it to be recorded, you record it. If you want it to satellite over SDI or over 702110, it doesn't matter. It will always be able to deliver a signal.
The new tool set will allow RTBF to navigate its technological revolution. And yes, we are all very proud and also amazed at the end result, which goes beyond what we had imagined at the onset of the project.
The OB twins are the first building blocks of our Media Square project. The IP technology they use and RTBF's desire to transition towards future-proof technology will allow us to work on an abstract level that is independent from the formats we use.
Hello, my name is Dion Lecointe. I am the head of IP technology for Sony's Imaging and Professional Solutions of Americas division. Last year, we announced a powerful partnership with Nevion, a worldwide leader in real-time IP media networks and virtualization. With SMPTE 2110 now fully integrated into our products, we are broadening IP effectiveness with control and orchestration software for facilities and across enterprises. The platform enables our customers to create shared production environments, build dynamically scaled networks, automate production workflows, schedule resources and services, and flexibly use resource pools, really virtualizing those resources on demand. The platform also enables a number of powerful optimized workflows driven by IP. They include remote production, which has already been in place for a number of years, in-facility shared production, inter-facility shared production, and shared production amongst OB vans. Let's walk through these in the next few slides. Remote production, or REMI, is a workflow that has already been in use for a number of years by content producers. It allows for fewer production staff to be needed on-site at the remote location, and it also allows for production staff at master control or your broadcast facility to produce more than one event or show on the same day without the need for travel. A great example of a solution in Sony's portfolio is the new HDCE TX30. This solution offers the ability to create SMPTE 2110 or NMOS connections directly at the camera head with or without the need of a CCU. By connecting this solution to a camera head via a SMPTE fiber cable, you're able to get all of your traditional camera signals in a SMPTE 2110 stream that you can directly connect to the network. In-facility shared production is really allowing studios and control rooms to share production equipment that is within a single facility. It allows you to have more effective and efficient use of those production resources. For example, utilizing a production switcher that is traditionally dark throughout the day for REMI in the afternoon when it's not being used. It can allow for changing the combinations between control rooms and studios by utilizing the live element orchestrator or the facility management layer in the end-to-end platform. Shared production amongst OB vans has long been the holy grail of mobile production. Imagine having a home and away truck from two mobile production truck providers with different IP networks connecting to each other using a single network via SDN, and now able to share camera chains, high frame rate streams, and able to share production resources to put on a large sporting or live entertainment event. And then there is inter-facility shared production, connecting multiple production facilities in IP so that they can share production resources across an enterprise LAN or enterprise WAN. Imagine a production switcher stationed in Los Angeles being used to run a show in New York during the morning show hours, and then dynamically being reallocated to the Los Angeles facility in the afternoon. The same can be done for graphics. The same can be done for replay, all by virtue of IP and a network dynamically controlled by SDN, and your production resources dynamically controlled by facility management, allowing you to book a resource very much in the same way you would book a conference room in your own office. We are very proud to say that any product in our live production portfolio is SMPTE 2110 ready. We're also very proud to say that they support the latest interoperability standards from ANMA, NMOS ISO 4, and ISO 5 through the Joint Task Force on Network Media. IP really represents a transformative change for the media and entertainment market. If you are considering building a new facility or retrofitting your existing production facility, you should absolutely be considering IP. And hopefully you are also considering reaching out to Sony to help guide you through your transition process into an IP facility. Thank you very much for your time.
Hello everyone, my name is Lawo. I'm pleased to be here with you today, virtually speaking. The North America team asked me to give you an overview of what was Embryonics product and what are now the MediaNet IP products. So let's start with the beginning. At the beginning, we started in the SFP form factor. The goal when IP come on board was to really take this SFP, plug it in a switch, and enable you to go from an SDI to an IP, and always in miniaturization. So you minimize the cost, you minimize the weight, you minimize the failure block, and of course you minimize the price per gateway, per port. So let's go back in 2016 now. In 2016, for a big world event, the broadcaster asked us to do a box to go behind a monitor. So we created the Fusion. So the Fusion tree, it's really simple. It's a tree cage, so you have two redundant network and you have one output or two outputs. The Fusion 6 box came after, and the goal was to give you more IOs, so optimizing the network IP path. So those are the two boxes that we created after. And then came the all IP processing. So the goal is to create a new one. So this small guy, as you can see, there's no more IOs. And this small guy enable you to really fix the problem like, oh, I need an up-down cross. Oh, I need a multi-viewer. Believe it or not, there's a 16 image multi-viewer in there. Let's say you're missing some space in your studio or your OB van or in a remote facility. So then you use this guy and you can do a multi-viewer full IP. So there's no more IOs. And to give you more power and more processing, we created the Virtue. The Virtue, it's basically a hub. It's a passive hub, a passive connection that you can plug up to 32 of these guys to create up to 64, let's say JPEG XS codec. So you can have encode or decode 64 channel, and they're microservices based. So you don't, if you lose the power of one, you don't lose your entire 64, which is the really key there for us. So to provide you with functionality, but also to provide you a minimal failure block. So if there's anything goes wrong, you don't lose all your 64 channels. So to summarize, we started with the SFP, the gateway first, and then we go with the Fusion boxes, and then we go with the new one that do processing. Oh, by the way, it's the same processing core for gateway or this one without IOs. So you can reuse your code in both, no problem there. And then to give you more processing power, we created the Virtue. So I hope this was informative. And for more use cases, please visit Riedel.net and we'll put more use cases there. Thank you very much for watching. I'm Renaud Lavoie with Riedel Communication. Thanks a lot.
Okay, and thanks again to Mike Francis, EVS, Imagine Communications, Lawo, Nevion, and Riedel for those great presentations. Obviously, be sure to check out Part B with Adder, IHSC USA, MarkerTech, and Vitech. And great to see you all, and hope to see you all soon. And be sure to check out all the other tech tours as well as time permits. So thanks again for joining us, and see you all soon.